Okay, today we're talking about dilations. And really the big picture of this is enlarging or reducing a shape, as we talked about with similar shapes, and there's a scale factor. The big difference here with dilations is it happens in a specific direction or about a specific center point. As you can see in this image here, we've got this point C projecting this triangle PQR to make it larger. So we can multiply this by, some distance, but really what's happening here is we have this distance between the center and P growing to maybe twice as long, 3 times as long. And so really point P is getting further away from the center point. And again, the same thing, R here is getting further away. But because of SAS, similar triangles here, we have that similarly P prime and R prime are now in that same ratio distance. So if this line got twice as long and this got twice as long, this side got twice as long. So I'm going to just show you a quick animation of this. Okay, so this is, just looking here, this is some original shape. And what we're going to do here is we're going to say, okay, let's take a center point. I can put the center point anywhere. I could put it inside the shape, outside the shape. And then we're going to choose some scale factor with regard to this center point to enlarge this shape by. So I know I could make every single side length here twice as long. Whatever BC is, I could make that BC get twice as large. However, I want to do it specifically around this center point. So if I put the center point inside and show the image, it projects outwards. Each point, A, B, and C, gets further away from the center. However, I could move that center point anywhere and it projects. And let me just connect with some lines here. You see that the distance from the center to C is now getting twice as far to C prime. The distance to A is twice as far from the center to A prime. Now, I could put this center anywhere I want, and I could as well enlarge this and say, actually, I want it to be 3 times as large. Or I could go down to a 1-to-1 scale factor. So the distance from the center to C remains the same, and C prime stays where it's at. Or if I multiply that distance by a number less than 1, it actually gets closer and closer to that center until it disappears to nothing. And so I can shrink or enlarge this just like putting 2 fingers on the screen of your phone. And you can enlarge it and zoom out and make it any size you want. Now, when you do it on your phone, the center point is right between your 2 fingers. So as you enlarge it, the image stays centered on what you want to look at, right? It wouldn't be very helpful if you enlarged it and then it went out of the screen and you're like, wait, what was I looking at? Okay, so let's go back to the notes now. Okay, so now when doing a dilation, you need 2 pieces of information. You need the location of the center point, and as well, you also need that scale factor. And again, what's really happening if the scale factor is bigger than 1, the points are getting farther away from the center point, so your shape gets correspondingly larger. If the scale factor is less than 1, the points are actually moving closer to the center point. And so just, to draw it again, you have 2 points here and here that get closer to the center and are hence closer to each other. And so the shape gets correspondingly smaller. All right. And I like to think of it like this. I mean, there's really 2 ways I like to think about this. Either I like to think about it as I've got a flashlight here. Okay. And this flashlight is shining at some sort of cardboard cutout. So let's say it's that same triangle. And what happens is it casts a larger shadow on the wall. Okay, and I think about my center point as the flashlight. Because if I move my flashlight, if I take this flashlight and move it up or down, the shadow will move in the opposite direction, right? So I could point the flashlight in whatever direction I want. And that's like moving our center point. I can project the resulting image anywhere I want, right? The second part is I think of this like the scale factor being how far am I going to move this away from the wall. Because if I take this and move this backwards, now the resulting image is that much larger than it would have been. And I could move far enough away where I could cover an entire car or a building with just the shadow of a little cardboard triangle, right? Assuming the flashlight was strong enough. Okay. So let's actually do some sketching here then. So copy this diagram and then draw the given dilation. So we have two here. These are both homework problems from the book. So the main idea, and these are just sketches. You can absolutely use a ruler to do this accurately. But the big idea here is from the center point, you connect to the point you want to project. And again, for the number 7, I'm starting at H. So I would go to E and I would keep going through E. This is just scratch work. Okay, I'm also going to want to enlarge through F, so I'm going to go out in this direction. Okay, through G, so I'm going to go out in this direction. Oh, that one didn't straighten. Let's do that again. Okay, so I want to go through G, and now I want to go through D. Now, you would use a ruler for this, or some, just the tip of my pen. You can't see it, but I'm measuring just the tip of my pencil, so I get my image to be somewhere around here. For E prime. Now I'm going to say, okay, this is, about, okay, so it's going to end up somewhere right about here. This one, I'm just taking this distance and copying it over here, so it's twice as long. I'm going to take this distance and copy it down here, so it's twice as long. You get something right about here. So here's my F prime, my G prime, and my D prime. Now these are just sketches. They don't need to be perfect. But here's your resulting shape, okay? This resulting shape, if I were to measure any corresponding sides, it would be a scale factor of 2. So any measurement I took, let's say the height dg, this height d prime g prime would be twice as tall. If I were to measure a diagonal, any other side length you could think of, the resulting image would be twice as large. Okay, now we could project this differently. So over here on number 9, you've got the exact same scale factor. So the resulting image is going to be just as large, right? It's the same original shape, twice as large. So it's going to be the same image as number 7. However, what we did is we moved that flashlight. So instead of shining from the inside, H, on number 7, we're actually shining from the outside. And so just to ballpark it, it's going to be coming somewhere over here now, and we're going to get something like this. So let's be a little more precise, okay? Starting at J, going through D and continuing, we get something like this. Through E, we get something over here. Through G, we get over here. Through F, ooh, I missed it by a lot there, but it'll straighten itself out. So in a different color here, let's say, okay, so about this distance again, we'll get about, and this is just a rough ballpark, D over here. E would go about here. Okay, J would go about here. And, or I mean not J, that was G, sorry. And F would go somewhere about here. So then I could draw my resulting shape. I was a little off because that side is a little slanted. Right, but there we go. And I can just really quickly, I just want to see how accurate the ballpark was. I should be able to take this shape and line up with the original, and that's give or take a little bit margin of error. It's the same size as the other image. It's just projected in a totally different direction, right? So instead of exploding outwards from this inner center here, the flashlight is over here projecting in this direction, okay? That's the basic idea here. Now I'm going to get more detailed about how you do this on coordinate plane, because the two main types of problems you'd see would be sketch a dilation, so like this. I mean, using something straight edge, like a ruler, the side of a binder, but sketching the distance. Or on a coordinate plane, you could accurately move points. So on a coordinate plane, all you do is you say, okay, so here's the example problem. Dilate triangle DEF about point C. So point C is our center by a scale factor of 2. Okay, so I'm going to project, starting at point C, each of these 3 points, D, F, or that was E, D, E, and F, outwards twice as far. The way you do that is you simply say, okay, step one, how did I get from point C to point D? Okay, so my path, and it doesn't matter what path you take, but horizontal and vertical are easy to count. We're on a coordinate plane. So I'm going to go left 3 and down 3. Okay, so that was my path to get there. Well, if I want to go some scale factor as far, then what I do is I multiply the scale factor by both the horizontal and the vertical. Okay, so if I was going over 3 and down 3, I just take my new scale factor of 2 and say, I would like to go exactly twice as far as that. Okay, so multiplying by 2, we get a new distance of 6. If our scale factor was 1/2, we would have, over here, I'll just do it in green, we could have done 3 times, 1/2. That's our over, and down would be 3 times 1/2, and we would get over 1.5, down 1.5. That would be if the scale factor is 1/2. We would go half as far. Okay, so whatever the scale factor is, you just multiply it by the horizontal and vertical components of your instruction. So now we've got a point that's 6 over and 6 down, so that's where we place our D prime. We do the same thing with our others. So E was down 2 over 1. So taking 2 and 1 and multiplying them by 2, we get that that is now 4 and 2. So we're going to go from the center down 4 and over 2. There we go. That's our E prime. Now really what we're doing with the scale factor 2 is we're just saying instead of going down 4 and over 2, we could think of just doing 2 steps. We're going down 2 over 1, down 2 over 1, and in total we've gone 4 and 2, right? Down 2 over 1 gets us halfway. Down 2 over 1 is our second step. So we're just saying take, oh my gosh, I went down 4 and only counted 1 over. Down 4 and over 2, E prime is right here. We would have caught that in just a second when I double check. And I'll show you, well, I'll leave that there just to show you later. Okay? And to go back to, well, let's do even another color here. So to get to F, we went down 3 and over 1. So our path 3 and 1. We multiply by our scale factor. So now we have a new path that's down 6 and right 2. So down 6 and right 2, we end up here for F prime. Now this note in pink here says the line connecting your image point and your center should always pass through your pre-image. So if I take, and I'm going to make straight lines matching these colors. I've already got this pink one here, but if I take a line from D prime, connect it through D and back to C, right? This is my line I'm showing you. If I connect it to C, it goes right through my original D, right? So the image, the pre-image, and the center are always on a straight line. And going back to the very first picture, you can see that, right? If I connect center to P prime, there's a straight line connecting it. Center to R prime, straight line. Center to Q prime, straight line. Okay, so let's go back down here. So let's check it, right? So my blue point, if I connect C to F prime, I get exactly a straight line. If I take my green and I go C to E prime, oh no, my original E prime was off. So I go, oh, let's undo. I found my mistake and I say, oh, now I got it with this one. It does pass through. So my new point is correct. I'd erase my old point. I'd say, get that old error out of here. Great. And then I go in whatever color and draw my new triangle like that. And it's got that three-dimensional pyramid look, which is kind of a key, like, okay, I did it correct. It's got those straight lines connecting to the center. All right, so let's try it out now, okay? So I'm going to do scale factor of 3 on triangle ABC here. So I used to go up 3. I'm going to multiply that path by the scale factor. So my new set is 3, 6, 9. Here's my new A prime. Okay, I took my path from the center point to the first point I chose, A. My set of instructions was go up 3, and so I want to be 3 times as far from my center point, so I multiply it by 3. From my center point to point, oh, I shouldn't have had 2 point C's, that's just confusing, okay? So from the center down to C, it's a distance of 2. If we want to go the scale factor far away, we go times 3, and we go 3 times as far would be 2, 4, 6. Down here would be C prime. And then B was over 3 and down 1. So, I'm going to be off the graph. Terrible teacher habit here, okay? So don't do this at home. But I'm going to multiply this path by 3 times 3 times 3. So my point that's 3 times as far away would be over 3, 6, 9. Now don't add graph on your own, but sorry. So what I'm going to do now is go over 9 and down 3. So my new point would be right here. Here's B prime. Okay, and I'm going to connect that. This is my new shape that is 3 times as large, but centered, more importantly, around the point C. Okay, scale factor of 1/2, about that center point C there. Well, let's do this. This is a little trickier. So my first set of instructions to this bottom point right here is go down 1, 2, 3, 4, 5, 6. So 6, I'll do it off to the side, 6 times the scale factor. 6 times 1/2 is 3. So that point comes here. Okay, let's label these. So A prime, B, let's skip C and go D and E. Okay, to get to, and I'll do this in a different color so it's clear, to get from the center to B, my path was go down 1, 2, 3, 4, 5, 6, 7, 8, 9. So I had a path of 9. Scale factor 1/2, I'm going 4.5 down. So I'm going to go down 3, 4.5. So here's my new B prime. Okay, I'm going to do that the same thing with each of the other shapes. So in a different color here, my path to E was over 1, 2, 3, 4, 5, 6, 7. 7, yeah, and down the same 6, so 7 and 6. So if I multiply each of those times 1/2, I'm going over 3.5 and down 3, and there's my point, E. Now really, or E prime, now really you could just figure out, since this was a rectangle before, I could tell by the perpendicular 90s here, that our last point D prime will be 3.5 over and 4.5 down. And so I'm going to draw my shape, and then just to double check at the end, I always connect my image points to my center and my original pre-image to the center. So let's do it in a totally different color. Let's do it in brown. Okay, so E to center, bam, right through E prime. D to center, oh, I said F. D to center, oh, it misses by a little, but 1/2 and 1/2, it was a ballpark. And then connecting these, of course, these go through because they're vertical lines. But there we go. It wasn't large. You can measure any side. It's 1/2 as big. Great. Okay. So I'm going to give you 2 last notes here. That's the big idea. Okay. One trick that only works when you're doing a dilation around the origin or 0, 0 is you can just multiply the x and y coordinates by the scale factor, which is essentially what we just did, right? So if I wanted to do this by a scale factor 1/2 about the origin, I could say, okay, well, this point is -2, 6. And I could just multiply both of those by 1/2 and turn this into timesing by 1/2. I could get that that's -1, 3 if I make it half as far away from 0, right? So now -1, 3 is right here for our C prime. But that's exactly what we just did up here, right? Whoops, up here. Because how do you get from 0, 0 to a point? You do exactly that path, right? That xy is just a path. It's saying go left 2 and go up 6. Multiply both of those by 1/2. And your new path is go back 1 and go up 3. So it's exactly what we just did. Some people find that helpful, but I'd say, again, be really careful because that only works when it's around the origin, because the x and y point happens to be the set of instructions to go from 0 to 0. However, up here, if I give you a random point C, you need to find that set of instructions. How did you start at this C, not at the origin, and get to our point, and then go half as far or twice as far, whatever the scale factor is. Okay, so let's do a couple homework problems now, and I'll jump onto IXL. That's the meat of the lesson. The rest is just going to be watching me do some practice problems, maybe pointing out a few things that you didn't notice. Okay, so find the scale factor here. Now remember, the scale factor says, I'm going to take, okay, let's just to write this out, I'm going to take my original distance, and I'm going to go times my scale factor, and that equals my new distance. Okay? Well, I could just divide both sides by this original distance, so my OG distance, and look at the same thing. Like just taking that original distance, multiply it by a scale factor, that's where I want to put my new image point, right? Well, that just means my scale factor is simply the new distance over the original distance, right? Because, I mean, think about it. If I take my original and I multiply it by the new distance over the original cancels out, and I get exactly the new distance I was looking for. So anyways, let's look at this. So what was the scale factor here? Well, I took an original 6 and I turned it into a 14. So my scale factor is, and we usually call that K, verse 3, my scale factor is 14 over 6. Or you could reduce that to be 7/3, right? And then it says, say whether this is a reduction or an enlargement. Well, we started with an original P and got bigger to P prime. So this was an enlargement. And then the last thing is find the value of x. Well, that's simple subtraction, right? If this is 14 long and part of it is 6, well, then the leftover is just 14 minus 6. The leftover is 8. Okay? The next one is going to be the same thing, right? If we have a total distance, I'll do this in a different color. If we have a total distance of 15, and 9 is part of it, then the other part is just 6. And so our scale factor here is, well, this is number 4, our new distance over our old distance, right? When you can see, did this thing get smaller or larger? We started with P, and it got smaller, so we'd expect a scale factor less than 1. Our new distance from the center to our image was 6, and our old distance, the starting distance from the center to our original P, was 15. So our scale factor here was 6 over 15, but if you divide by 3 on top and bottom, you get 2 over 5. Now, the last thing here, it said enlargement or reduction, so this was a reduction, got smaller. And the last one here, it says, okay, well, let's look at this. So we can tell by these straight lines connecting the image, pre-image, and center that this is a dilation. Just visually, we can see that, okay? And we can tell that, you know, Q prime corresponds with Q, R prime corresponds with R. So this is an enlargement. We don't know the scale factor, but remember, this is the same thing as with similar shapes. The scale factor is any corresponding part of this triangle over any corresponding part of this triangle. So the new over original, the ratio is 12 to 8 because R prime and P prime correspond to P and R. And this is a dilation, right? So let's see, 12 over 8 is our ratio. We can reduce that by 4 to get 3 over 2. And so if we want to solve for x, well, we'd say, okay, in number 5, we'd say 15 is to x as 3 is to 2. Cross multiplying, we get 3x equals 30. Dividing by 3, we get x equals 10. Was this an enlargement or reduction? Well, we started with a P here, and it went to a larger image, so this was an enlargement. Right? Now going on to 6, it's a error analysis. So this one, let's see. Well, we have a total distance to the original of P. that's 12. We have a total distance to the new image, P prime, that's 3. So over here, we should have new over original. The new distance is 3. That got shrunken down from an original distance of 12. This is a 1/4 reduction because our starting image was big and our ending was small. But oh, they told me the scale factor was 4. That would mean our shape from the center would have gotten blown up to be 4 times as large. I wonder how accurate that is to 4 times. I'm curious. Okay, anyways. But that's the idea here, is the new distance compared to the old, because what we want to see is what's the result. And if we say our result is 4 times as large, then we would expect something like this. But we want a new image that's 1/4 as big to end up looking like what we got here. Okay? All right. So one last interesting one I thought was really good before we just practice some dilations is what if we have a dilation that maps 5,1, that's A, to 2,1, okay, that's A prime, and 7,4 to 6,7. Oh, going off the graph twice. Poor planning, Mr. Dilloughery. Okay, well, first find the center of dilation. Where is the center of dilation? Well, let's see. It went from A to A prime and from B to B prime. So where did those originate from? Those must have originated from back here somewhere. I don't know where. And this one must have originated back here from somewhere. I don't know where. But oh, look, they must have come from right here. Here's the flashlight. We traced it back, right? And we know that this is a straight line. So if I just continue this pattern of down 3, back 1, down 3, back 1, I get to this point, which is 8, 1. That is our center of dilation, 8, 1. Okay, interesting. And what's the scale factor? Well, we went up 3 and over 1 for one step, right? But now we went up 6 and over 2. So if we just take any one of those and say, well, what's the ratio of new to old? That is 2 to 1. So our scale factor is 2. We went twice as far. This distance was 3, and the new distance is 6. So the ratio of 6 to 3, new 6 to original 3, is 2 to 1. Okay, that's just an interesting problem. So now I'm going to switch over to IXL and just practice some problems. Stick with me. If you feel like you've got it, you can go ahead and move on. Okay, so this says, graph the image of the rectangle after dilation with a scale factor of 3, center around the origin. I'm going to turn on my pen here. So what we've got here is a distance of 3. I want to take that distance of 3 from the origin and multiply it by my scale factor of 3. So my new point is going to be 9 away. So I'm going to take off that original pen. Let me get rid of this. So I'm going to take off this. Shoop. Okay. So now I'm going to switch back to the pen. I'm going to say, well, this one was 3 and 3. So I want to go, again, 3 and 3. If I multiply 3 by a scale factor 3, now I want to go up 9 and over 9. So I get my first 2 points are there and there. Okay, let's take this off. So I'm going to move this point up to here. All right, there we go. It's hard to draw on the graph and do that, okay? So I'm going to do the same thing on the left, but we actually get it's the same path because it was 3 to this one and it was 3 and 3. So it's a mirror image on the other side. Just taking this off, what we get is this point at 9 up and 9 over, and this point at just 9 over on that side. Okay, so this is a scale factor of 4 centered at the origin. So I'm going to draw off the graph this time. So to get to A from the origin, because it's a center at the origin, I was going up 2 and back 1, but I want to multiply both of those by my scale factor. So times 4 times 4. My new path for A is 8 and 4. Okay, so I'm going to go up 8 and back 4, and here's my new point for A. All right, then from B, I was going from the origin up 2 and over 2 to get to my point. So if I multiply both of those by 4, my new point for B is 8 and 8. So I'm going to put that point over here, 8, 8. For C, I was just going down 2 from the origin. And so I would multiply that by 4, and my new path for C is down 8. So I'm going to say right here is my C. Okay, so scale factor of 5, the numbers are getting bigger. I wish they'd give us a fraction here. Okay, so for M it was 1, 1. I'm going to multiply by 5, and we get 5, 5 is our path for M. So M goes up to 5, 5 over here. For L, it was up 1 over 2. So multiplying by 5, we get 5 and 10 for our new path. So up 5 over 10. For K, it was down 2 and over 1. So multiplying by 5, we now have 10 and 5. So down 10, back 5. Oh, I should have done this in order. But because it's a rectangle, I know it's going to be right there if this point was there, just completing the rectangle. Okay, so another one at 3. This is actually very similar to the last one. So R was 3 and 3. So multiplying by 3, we get 9 and 9. S was 3 and 3 this way. So we're going to 9 and 9 over there. Okay, down it was down 2 over 3. So we're multiplying by 3. That's our scale factor. We're going down 6 and back 9 and completing the rectangle over here. All right, so now we got a triangle scale factor of 4. So instead of up 1 to S from the origin, we're going up to 4. That's our first point. R was 1, 1. Multiplying by 4, we're going up 4, left 4. T was down 2. So now we're going down 2 times 4 is 8. Oh, here's our first fraction. Okay, well, let's start with S. S was over 5, up 5. If we multiply those by 1/5, 1/5 of 5 exactly cancels out to be 1. So we get our new path is 1, 1. Because we're multiplying by a fraction less than 1, we're going to get a point closer to the origin. And again, it's because it's centered at the origin here. So to T, we were going up 5. Multiplying by 1/5, we get now our new path is just up 1. So there's T. Okay, R was down 5. So multiplying by 1/5, our new path to R is down 1. Whoops, I didn't do it in order again. Okay, and to Q, it was back 5, down 5. Multiplying by 1/5, we get our new path is 1 and 1. So I'm going to move this over here, and there's our shape. Okay, I hope you enjoyed this video. Yeah, good luck.